all the colors. It looks like a rainbow.
Did you ever hear that at the end of a rainbow you could find a pot of gold? Do you think that's really true? Have you ever seen a rainbow? Well, suddenly, it just appears in the sky as if it came out of nowhere.
What causes a rainbow?
Well, first you need some rain. And then you need some sunlight. When you think about it, that's an unusual combination. We don't often see rain and sunlight together. Maybe that's why we don't often see rainbows. The next time you see rain and sunshine at the same time, turn your back to the sun and look for a rainbow in the sky.
Where do all those colors come from?
Let's try an experiment. You can make your own rainbow colors with some water and some light. What happens if we turn off the sun? This seems to show that the color comes from some effect that water has on sunlight. You have seen the same rainbow colors when oil or gasoline is spread on the surface of water. Some types of oil work better than others. You might see rainbow colors when you least expect them, like when you're just having fun. But what if we wanted to study rainbows? How could we do it? We don't often find that combination of sun and rain. Let's build our own scientific model. Then we can make a rainbow whenever we want one. We'll try a garden hose with a spray nozzle. We'll pick a nice open place with the sun behind us. We'll also need a dark or shaded background. Well, it appears that we can make a section of a rainbow whenever we have sunlight and a hose with a spray nozzle. Let's try this at noon when the sun is at its highest point. When the sun is high in the sky, we don't seem to make much of a rainbow. And late in the day, when the sun is low in the sky, we seem to be able to make our best rainbow. It looks like part of a circle, doesn't it? Let's make some notes and diagrams of what we just learned from our scientific model. A scientist usually makes measurements. So let's see if there's something we can measure here. We can try to measure the distance from where we are standing to the rainbow. But there doesn't seem to be anything there to measure. How would you measure the height of the rainbow? If you walked to where the rainbow appeared to be, what do you think would happen? One thing's for sure, you'd get very wet. So, what did we learn about rainbows from our scientific model? We learned that the angle of the sun above the horizon determines whether or not you see a rainbow. When the sun is high in the sky, there is no rainbow, at least none that we can see above the horizon. When it's raining and the sun is low, you'll probably be able to see a rainbow if you turn your back to the sun. We also learned from our scientific model that it's hard to measure the height and distance of a rainbow, because there doesn't seem to be anything there to measure.
Can you measure anything about a rainbow?
Yes, you can measure the angle of the rainbow above the horizon. This is how you measure the angle of something above the horizon. If you are standing here, and the rainbow appears to be about here in the sky, and the horizon is here, you can measure the angle between these two lines by thinking of this as part of a complete circle. If a complete circle is 360 degrees, you can see that this part of the circle is about 30 degrees. That is the angle of the rainbow above the horizon. This simple tool lets you sight the top of the rainbow and read off the angle in degrees. You can make your own angle finder. Start with a protractor and a piece of wood. Hang a weight on a string, attach it to the center. Now, sight along the top of the wood and then find your rainbow. Then have someone else count the number of degrees the string has moved from zero, or level. We can use this system to measure the angle of any object above the horizon.
Okay, but how does sunlight and water make a rainbow?
Well, to understand what makes a rainbow, you first have to understand a raindrop. When a drop of liquid falls from a high place, it forms a sphere, a completely round drop. Sunlight entering that sphere is reflected and refracted. The word refracted means the light is slowed down and bent as it passes through the water. This happens because water is a more dense material than air. The combination of refraction and reflection separates the white light of the sun into the colors you see in a rainbow. When you look at a rainbow, you're seeing a reflection of the sunlight refracted through thousands of tiny raindrops. Sort out the colors. We can create the same effect in the laboratory. Prism gives us the same rainbow colors. A beam of white light is refracted or slowed down as it passes through the glass prism. Since it travels through different thicknesses of glass, the beam of light is separated into colors. Why do you suppose this glass of water has the same effect as a prism?
So why do we see rainbow colors when we put oil on water? Why do we see rainbow colors on a soap bubble?
If you apply what you've learned today, you'll be able to answer those questions and learn a lot more about rainbows and about light and color. Drop. Sunlight entering that sphere is reflected and refracted. The word refracted means the light is slowed down and bent as it passes through the water. This happens because water is a more dense material than air. The combination of refraction and reflection separates the white light of the sun into the colors you see in a rainbow. A beam of white light is refracted or slowed down as it passes through the glass prism. Since it travels through different thicknesses of glass, the beam of light is separated into colors. What you are really seeing in a rainbow is a reflection of the sun's light refracted through thousands of tiny raindrops. There's really nothing there but a reflection. Do you suppose that's why no one has ever really found that pot of gold?